So this is about heart rate, death rate, and it is very elementary. And so first of all, we want to know what is mathematical modeling. We want to see the real world and try to observe what is happening in the real world. And then we want to express this observation with mathematical formulas. And we know how to find the solution for the mathematical equations. And then we interpret that comparing with the real data. So our motivation for this is that we think that our audience is like not very high. Their background is very, let's say, not very well defined. So undergraduate students. So our goal is to teach them in such a way they will appreciate modeling, just the mathematical modeling, without worrying much about technology and programming. Because some of our students, they are not, they don't know a lot about the technology and the programming. So this is a data that I received from teaching business math. And here it tells us that during the year 2000 to 2010, the death rate due to heart failure or heart or stroke or related to heart is like this. And if I see this, I see that this is a kind of a decreasing trend. And we can ask this question that we know heart disease is the leading cause of death even now. So how come this thing is decreasing? So actually since 1950, the death rate has been decreasing very sharply because the doctors, they found out the major risks for this are cigarette smoking, high blood pressure, elevated total cholesterol, obesity, diabetes, or physical inactivity. So once they found out these things, and if they treat this early or give the medicine, prevention and treatment, they found out that we can reduce this death rate. Hence, this data makes sense that it is decreasing pattern. So for this lecture, we have this task. Let's first build a mathematical formula, which is algebraic, and then we will find out some difference equation method. Then we will build the differential equation model, and we will talk about parameter estimation. And after that, we will compare all of this with the data. So first, when I got this data table, I saw that this is given in terms of year. So let's try to change it in terms of time. Let's think that year 2000 represents the initial time, and every 2 years the data has been taken. So now my new data is given in terms of time, and this is the death rate. And this is a very small data table so that student will appreciate about the data. So now let's try to get how this data looks like. I use the Excel to get this data, and you see that it is a decrease, it shows the decreasing pattern. Hence, my goal is to find out an equation which is algebraic, and we know that because it is decreasing, so therefore we want to write down some exponential model. And before we do, the mathematical model development tells us that we need to derive our variables. So let's first choose T for time and HT for heart death rate. And hence, and as I see from the picture that it is decreasing, I can write down one algebraic equation which is exponentially decay. So HT given by H0 times B to the power T, where H0 is some constant. Here in this case, our thing is the initial time, initial heart rate, which is 257.6, and B is unknown base we want to find out, and T is the time. This is with time. So question comes, how we are going to write down this equation? So from the data, we see that at T equal to 0, this is the data, and this formula is satisfied when T equal to 10. So let me take when time equal to 10, this should be also satisfied. So if I replace this by T equal to 10, therefore I got this equation, and I know what is H at 10 is 178.5. I will put this here so that this is an algebraic equation, and I need to solve this to find the value of B. So B to the power 10 is this. Therefore, if I take the 10th root, I get the value for B equal to 0.96 and so on. Hence, I will write this equation in terms of HT equal to 257.6 times 0.96 to the power T. So with this, if I use, this is my new formula to find out the death rate due to heart disease, and I get this equation, and I calculate this. Again, I got the Excel spreadsheet to calculate this. And we see here, this blue one shows the actual data that is given in this here, and the red one is the exponential data that we derived using this formula. And this is a very good match. So the next question is, can I derive a difference equation model for this simple data? So what I'm going to do, that this is my data table, which was given in terms of time and death rate. It was given in terms of time 0, then after 2 years, and so on. Now I'm going to represent in discrete form, where I'll say that this is my starting observation, that 0 is equal to 257, and then the next observation is 1 is 240.8, and the next observation is 2, and so on. So instead of writing T, I'm writing N, which is a counter or iteration. So my goal is to say that this is my HN represents the old data, and my goal is HN plus 1 is the new data. My goal is to find out that determine the new data heart rate from the old value HN. So in mathematically, I can say that new heart rate is nothing but the function of the old one. So the question comes, how I'm going to write down a formula for this one, mathematical formula. So I can write down in 2 ways, difference and the ratio. So what is the meaning of difference? So I'll take this new data, let's say this is new data and this is the old data. I'll find the difference between this. So this gives me this minus this is minus 16.8 and so on. So, or I can say that the ratio between this new data to the old one. So if I take this, I get these values. Looking at these two things, I compare, I see that for the difference, I do not see any pattern here. However, if I see this ratio, I find a very nice pattern, which is something like a very constant like 0.9. Therefore, I can write my equation like this. So I'll say this Hn plus 1 divided by Hn is equal to some constant k, which is equal to Hn plus 1 equal to k times Hn. And what is this value of k? I do not know. So I'll just choose this k is equal to, let's say, 0.9 from here. So if I choose that, then I get my equation, the new value equal to 0.9 times the old value. I can also write down this value of k in a different way. I'll take all these values, add this together, and find the average of that. Then it turns out to be something 0.93. So I can write down my equation as Hn plus 1 equal to 0.93 times Hn. So if I choose these two formulas, and I can generate my data using this formula or this formula, I can compare with the actual data, and hence I get this graph. Here I see that the blue points are the actual data, and this green one, which is due to the average value, I get a pretty much very close connection between the model and the actual data. So now my goal is to write down the differential equation for this. To write down the differential equation, this is my actual data that in terms of time, and this is my death rate. So once I put this graph, it shows a decreasing pattern. And from the differential equation, we know that we can write down this as a differential equation as derivative rate of change of the heart rate is equal to negative K times H. What is negative? Negative tells you that it is decreasing. And K is some constant which you do not know. And here, the beginning at time equal to 0, the heart rate is given by that. So this is my initial condition. Hence, I wrote my differential equation like this: dH by dt equal to minus K times H with initial condition is this. So this is my initial value problem. Of course, you can use separation of variable to find out what is the solution of H. And because we want to appreciate our mathematical modeling, so what I will do, I will go to Wolfram alpha. So Wolfram alpha, which is like a mathematical form. So here I will just use the command solve. Solve, let's say H prime t equal to my initial minus K times HT, minus K times HT. That is my differential equation that I have. Sorry, T. And with the initial condition given by H at 0 is equal to 200, how much? 257, 257.6. So within a click, I get my answer, so students will appreciate. So this is what we wrote correctly. So this is my answer, that 257.6 to the power e to the minus kt. So this is my initial value times e to the minus kt. So this is a good way to keep track of our modeling effort, not necessarily going to the mathematical details for this simple problem. So we got our solution. Now with that solution, let's write down our, find our data. For this, I do not know what is the value of K. So let's guess the value of K as a beginning and then try to see what is happening. So this procedure I'm going to show you using my Excel spreadsheet so that you can appreciate this and students can also appreciate in the classroom. So let's say this is my actual data that I have taken. Now here, this is my model data that we got here, HT is equal to this one. So let me give some initial guess for this value of K. So let me write down K is equal to, let's say 0.3. So with that, let me write down my equation, which is equal to 257.6 times exponential exp time of minus kt. Minus k is this value, this cell. I have to fix that, F1, F4. So it will fix with the dollar sign, and then star time. Time is this one. So I will click that cell. So it will produce my value. So you see that if with the double click of this, I'll generate all these values. Now let me draw this graph using Excel spreadsheet with Excel. So scatter plot, let me get this one, scatter plot. So this is what I see. So look at this, this is my actual data. With this guess 0.3, it is not giving me anywhere whatever I want. So for a moment, let me choose this value, change this K value. Let's say this is 0.2. So if I put this and you see that it keeps on changing. So let's say 0.1, then you see that this one is doing better. So let me put something like 0.2 or 3, something like that. And you see that it is doing a very good job. Now the question comes, we cannot do this hit and trial method to get our value of K, which is our parameter we do not know. So how can we get this automatically? Of course, we can do the least square formula, and we cannot, it is a little bit a deeper study. And at this level, we want them to learn it, appreciate the modeling part. So therefore, we want to do it automatically using this Excel. So how I'm going to do? Actually, this Excel has the solver, which will help us finding this value K automatically. To do that, I'm going to find out how much error we are making due to this actual data and the model data. So let's go find out error. And please note that instead of finding error, I am going to find out the error square, which is a part of least square method that you take the square of that. So what is the meaning of this? That I can take the difference between the model minus the actual data and make a square of this. So if I just actually get only the error, then what will happen? There will be plus minus, and when I add all this, it will get canceled. Therefore, we make that as a square. So once we have the square, so we generate this value. Now let's add all these values to get our total sum. So I'm writing here sum error square. Sum error square is given by, I will add these values. So SUM sum of all these errors. So let's click it. Then it is showing me that is something is a 2,951. So it is a big error. So to get this automatically, what I'm going to do, I will go to Excel data, and it will show me somewhere here solver. So if you do not have the solver on this here, you can add in. And now I have this. So what I'm going to do, I am telling that what is my objective for this problem. My objective is that I want to make this error, the total error, to be small. So this is my error. I will click that cell, so it will show me here. So this is the error. I want to make it minimum, so it will be minimum. Then by changing who? By changing the value of K. So hold on. So I have to come here by changing, it's blinking, so it will take my this cell value. So I don't have to do anything. Now I'll just come here, click solve, and it will solve, and it is automatically giving me the answer. So the value of K is 0.03, for which the error has been reduced 66.31. And you see that it is matching very well. And if you want, you can also find out your R square value, which is given by equal to RSQ, SQ. So what I'm going to do, I'll just get these values of the actual data, and then with the model data, and we see that here this value is 0.98 and so on. The value for, if it is 1, then that is the best one, but we are happy with this. So this way actually I'm showing. So this way I'm showing that instead of guessing, we can create this value of K, which is our parameter, using solver from Excel, and so that student will appreciate the modeling part. Once they know what is this basic thing, they can use all these least square method and calculate by hand. So now at the end, I want to compare all these methods that we discussed: differential equation method, difference model, and exponential decay model. And in this all cases, I did the parameter estimation here, best parameter for this, and I generated all these values. And let's go compare with the actual data. And here I am showing that they are doing a pretty good job. So this is the blue point, they are matching. Measured data, model data, difference equation. So this gives a feeling that these mathematical formulas that we are doing giving us a lot about the actual data. So in conclusion, we showed the different methods for mathematical modeling, and we did the parameter estimation and compared all this data, all this method with the data, and found out a good comparison. And now, so at the end, I'll say, so this work has been published in CMOD, it's not staying, CMOD, and this actually did during this year's Denmark workshop, and thanks to CMOD, and thank you all for attending this meeting, this lecture. So hope you like it as when you are talking to the student who are just coming to the first day of classes. Thank you. So please, now you can ask any question if I would be able to answer your questions.
I would ask a question. Is there, you had data for 2000 to 2010, I think, or you had 10 years worth of data?
Yeah.
Is there a reason you stopped there, or can it go farther back in time, or?
Oh yeah. Although we think that still today, death due to heart diseases is the leading cause.
Yeah. Okay.
So that was somebody asked me that it is decreasing, but we still know that this is but the rate is decreasing. So okay. Yes, it has been started in 1950. So that is where they try to understand what are the real causes, so that once you prevent this, so they are going to reduce, but it is still the leading cause of death. And okay. These are the actual data, yes.
Okay, I would guess if you went back as far as 1950, you'd want to start adjusting for the population change as well to keep it, more as a per capita thing. But anyway.
Yes. This is actually I got when I was teaching business math, and I saw this is a small data, and I thought that for the first day of the classes for the differential equation or modeling, they will appreciate this thing. And once they understand the basic, they can go what you taught today.
Yeah. Okay. Thanks.
Thank you. So thank you for coming. And if you have any more questions, so we can discuss. Otherwise, we can dismiss and we can meet at the other conferences. Other lectures.